Today we're going to learn how to perform rotations and compare the pre-image and image of a figure after it's been rotated. A rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. And we talked about this in our last video. For now, our center of rotation is the origin, which is the point 0, 0. So it's usually in the very center of the graph. However, you could technically have the center of rotation be any point. Here is two methods to perform a transformation. And I'm actually going to do the second method first. The first is, if you know the transformation rule for a description, to write down the pre-image coordinates, do the math to find the image coordinates, and then plot the new image points and connect them. But you might not remember the transformation rules. Chances are, what if you have to do this next year? I don't memorize all the rules ever, because they don't always come up. So it's a little easier to just rotate it and then find out the rule. So I'm going to do this second method, which is reference the axes as spokes of a pinwheel. So this is how I envision it. Maybe you didn't have the same experience as a child as I did, but I remember having these pinwheels, and pinwheels, they basically have all these spokes, and then when you blew on them, they turned. Oh, that's not even a triangle. Sorry about that. So when you blew on them, they turned, right? And they're all facing different directions, and it kind of looks like if you were to make them look like an arrow, then the arrow is just pointing all around the pinwheel like this. So we're going to think of it like that. So the first step is we're going to draw or imagine an L connecting that point to the axes and then to the origin. So here's my little L, and then we're going to spin our pinwheel, and we're going to go clockwise. So we want to go in the direction that a clock goes. You might want to look at a clock, at the circle kind of clock, and then see. So it went 1 on the axis and then 3 out. So it goes 1 on the axis and then 3 out. So there's my new B, my B prime, okay? Then I'm going to erase this because it's going to get real confusing. For C, it was 4 along the axis. So I'm going to go 4 on this next spoke. Then for A, it went to C, and then it went 5 up. So it's going to go to C, and instead of going up, it's going to go 1, 2, 3, 4, 5 to the right. So everything kind of gets reversed, but when you finish your shape, it should look kind of like it's arrows kind of going around in a circle. Hopefully that makes some sense. Okay, so if you're going 90 degrees like we just went, then you move the L around the origin 1 spoke. 1 spoke meaning 1 axis. So think of the point as an arrow pointing around a clock. And then for 180, if we were to do that, then you're going to go 2 spokes. So it'd go 1 to that one, and then 2, it'd go on the other side. So if it was on the left of the original one, it'd be to the right, or if it was up, then it'd be down. It's going to look like it's going in the opposite direction. Okay, and then, plot the new point. So we did all that. Now let's think about what happens between these two triangles. They're angle measures. When I look at A, is it the same measure as A prime, which I didn't label correctly? That one's too hard to tell. I didn't do that one very well. If I look at B, is it the same angle measure? I think so. And then the C, yeah, it looks like this one is about 45 degrees and this one's about 45 degrees. So I'm going to say this is the same. Is it the same size? Yeah, it didn't get bigger or smaller, so we're going to say it's the same. You could also check just one side, like AB goes up 2 and right 3, and over here it's going 2 and then 3, so it's the same size. Okay, and then the orientation. Remember, orientation is talking about if we're looking at A, which point is on A's left versus right. And A, to the left of it is C, and to the right of it is B. So this orientation is actually the same. All of these are the same. Now, you may be confused. You may think that orientation is which way the whole shape is facing, and it's actually not. It's how the points are arranged in relationship to each other. So in relationship to each other, this triangle, it's not reflected. That's where we have a different orientation. This one, it just turns a little bit, but A, B, and C, like, they're all connected to the same person if they were people on the left and right. And then these shapes, because they have the same angle measures and the same sizes, these shapes are congruent. And you're going to find that rotations always give you a congruent shape, which makes sense. Just because you turn around doesn't mean you gained 10 pounds, right? Okay, we're going to go ahead and do our 180 degrees counterclockwise, and then we're going to explore what this looks like with coordinates. So 180 degrees, I could just erase this. 180 degrees counterclockwise versus clockwise is going to be the exact same thing. So we're going to take our points and we're going to go 2 spokes. So we're looking at this guy over here, this other side of the x-axis as our reference point. So C was 4 squares out that way, so it's going to be 4 squares out this way. Okay, now B, this is where it gets harder. People often perform a reflection instead of a rotation. So we want our spoke, instead of going up now, it's going to go 1 out and it's going to go down for B. That way it will properly look like it is a rotation. Okay, and then for A, it went 4 out and 5 up. So this one will go 4 up and 5 down. That's my A. And then there's my shape. Okay, angle measures are going to be the same. The sizes, those look the same to me. And the orientation, when I look at A to C, C is on A's left. And when I look up here, C is on A's left. You could also say, like, are you going clockwise or counterclockwise among all of your letters? So A, B, C. A, B, C. Like this one's clockwise and, wait, did I do that right? This one's counterclockwise and this one's counterclockwise as well. I don't know why I thought that was clockwise. That's funny. Okay, so these ones are also congruent. Now, if you're having a hard time with this, it may be better for you to memorize the function rules. So here's our function rules. 90 degrees counterclockwise is the same thing as 270 degrees clockwise, and their transformation rule goes XY, arrow, negative Y, X. And then for 180, it's still 180. It goes XY, arrow, negative X, negative Y. And then for 270, it goes XY, arrow. The Y and the X always swap when it's 90 degrees or 270 degrees. But this one is now going to have the negative on the other coordinate. So you could memorize these and just do it, or you could refer back to them, and that would help you out. Or you can just know that if it's 90 degrees, then the X and Y swap, and then you can think through which one's going to be negative. So let's look at this one. I'm going to find all of my coordinates. Whew, there's 4 of them, but I can do it. So A, the coordinate is negative 5, 3. B, the coordinates are negative 1, 3. C is negative 1, 1. And D is negative 5, positive 1. So I know that my coordinates are going to swap because this is a 90 degrees. If it's 180, then they're not going to swap. So we're just going to put, these here. And then we're just going to swap them. And then we're going to figure out if we should change the X or the Y. 1, negative 1. Okay. So it's going clockwise. So clockwise means that it will end up in this quadrant over here. Let's get some, this is my goal quadrant, right? So is 3, -1 in that quadrant? No, it's not. But 3, +1 is. So I'm going to change all the signs of the second coordinate. Now let's check to see if I was right. 90 degrees clockwise. Yeah, I changed the sign of the second one. Once I swap them, I'm going to change the sign of the second one. Sweet. Okay, now I'm just going to plot all of those points. So I need 3, 5 is A prime. 3, 1 is B prime. 1, 1 is C prime. And then 1, 5 is D prime. Okay, let's erase some of this writing here so I can actually connect the dots. And if you look, it does kind of look like the shapes on a pinwheel. It looks like you would turn that rectangle over as you're going. Okay, and just like before, all of these are same, and the shapes are congruent. It's always going to be the same when you're doing rotations. So those are your two methods. You could just use the rule, like I did in this example too, or you could imagine it as spokes of a pinwheel like I did in the first two examples.